8, 7, RS-25 engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
Good, roll pitch.
Roger, roll pitch.
After 8 minutes of violent shaking, gravity fades away. The 4 people inside the Orion spacecraft are not only leaving Earth, they are leaving the protection of the atmosphere to embark on a journey that humanity has overlooked for more than half a century. It has been more than 53 years since the last footprint was left in the fine dust of the Taurus-Littrow Valley. For half a century, the moon was merely a symbol in the night sky rather than a destination. But in 2026, that silence will be broken. They are Reed Wiseman, Victor Glover, Christina Koch, Jeremy Hansen. 4 names, but they represent a major leap forward for humanity. For the first time in history, a woman will fly beyond low Earth orbit. A person of color will go farther into space than anyone before. And an astronaut without U.S. citizenship will participate in a journey beyond the known limits of humanity. During about 10 days in deep space, the 4 astronauts will not only leave low Earth orbit, but will enter a region of space that humanity has left untouched for more than half a century, where distance makes all communication slower, any mistake more dangerous, and every decision a matter of life and death. I watched the live broadcast on both CNN and NASA's YouTube channel, and the experience was truly thrilling. At first, there were a few minor issues that made the atmosphere tense, but as each problem was resolved, everything gradually returned to its proper course. The most impressive moment was when the launch director called out to each team, and they all responded firmly, "Go." Then came the countdown, and about 10 minutes later, the rocket officially ignited. Even though I only watched it on a screen, I could still feel that overwhelming power. The CNN anchors said they were several miles away from the launch pad and could still feel the air vibrate when the rocket took off, enough to understand just how big that moment was. Before heading directly to the moon, the first 24 hours are a critical test. They must perform the rendezvous maneuver. Reed Wiseman and Victor Glover will manually control the Orion spacecraft using a joystick to simulate docking. They must ensure that the oxygen regeneration and CO2 filtration system works perfectly for all 4 people, because once the engines fire up to leave Earth's orbit, there will be no quick way back if the machinery fails. The main engine ignites, creating a bright flash in the darkness. Earth begins to grow smaller and smaller through the spacecraft's small window. This is the moment when humanity officially leaves Earth's embrace. The Orion spacecraft will accelerate to 39,000 kilometers per hour to overcome Earth's gravitational pull. The astronauts will feel the eerie silence of deep space. All communication with ground stations will begin to experience delays. Christina Koch will take radiation measurements to see how a woman's body reacts to high doses of cosmic rays outside Earth's protective magnetic field. The Artemis II mission is not to enter orbit around the moon, but to follow a free return trajectory. They will fly around the far side of the moon, using its own gravity to launch the spacecraft back toward Earth. At the closest point, they will be just about 10,300 kilometers from the lunar surface. Jeremy Hansen will be responsible for photographing potential landing sites for Artemis III. They will be able to see giant craters with the naked eye, an experience no one has had in over 50 years. As the Orion spacecraft ventures deeper into space and the distance from Earth increases, what appears before the crew is not just a destination, but a world completely unlike anything humanity has ever known, where the moon ceases to be a familiar bright disk in the night sky and becomes a gigantic, detailed entity so strange that it is hard to recognize. Among the first images sent back, there is a special moment when the camera captures a portion of the Orientale Basin, a massive crater nearly 965 kilometers wide, located on the edge of the moon's far side, marking the transition between the side visible from Earth and the mysterious far side that has always turned its back on us. And this is the first time in history that humans can directly observe this region with their own eyes, rather than through automated devices. For millions of years, the far side of the moon was a mystery, eternally distant from humanity. But today, Christina Koch is seeing it, not through a screen, but with her own eyes. Orientale, an eye of the storm of rock nearly 1,000 kilometers wide. It is the transition zone between the near and far sides. Before, only the lifeless lenses of robots had reached this far. Now, 4 human beings are passing over it, witnessing a majesty that no one has been able to see in over 50 years. As the journey continues, the moon grows larger and larger in Orion's window, filling the entire field of view and making everything else seem insignificant, while on the opposite side, Earth, humanity's only home, is reduced to a fragile blue sphere floating in the infinite void, offering a perspective that very few have had since the Apollo era. The images of Earth sent by Orion are not only beautiful, but deeply symbolic, showing our planet as a unique living system, without borders or divisions, just a tiny speck of light in the vast universe. And it is precisely this perspective that has changed the way astronauts view their origins. Thanks to modern technology, we no longer have to wait weeks for the footage to return. We are right there with them. Every smile from Victor Glover, every note from Jeremy Hansen is transmitted almost in real time, bridging the 400,000 kilometer distance between Earth and Orion. But the silence of space is a trap. Outside the spacecraft's thin hull lie solar particle storms capable of destroying human DNA in an instant. The crew must monitor radiation levels every second. If a major solar storm strikes, they have nowhere to escape. Christina Koch and Jeremy Hansen arrange water bags and protective gear around a narrow area near the spacecraft's bathroom. Here's a little-known fact. The best protected area against radiation on the Orion spacecraft is in the center, near the bathroom. In an emergency, their last stronghold is not a luxurious shielded room. It is a small, cramped corner where they will have to take refuge next to the basic life support systems, using bags of food and water as living shields to block the deadly radiation. Out there, hundreds of thousands of kilometers from Earth, there is no atmosphere or magnetic field to protect them. A solar storm can strike at any moment, releasing high-energy protons traveling nearly the speed of light. The Orion spacecraft does not have a room with thick lead walls. Instead, its best shield is water. The hydrogen present in water and food is the most effective barrier to slow down lethal radiation particles. They will have to remain there for hours, even days, until the storm passes. The trajectory used by Artemis II is called a free return trajectory. If any problems occur with the engines near the moon's gravity will automatically launch the spacecraft back to Earth without the need for additional fuel. It is an extremely important safety strategy for this first crew. Have you ever wondered why a spacecraft can travel at enormous speeds without colliding with other celestial bodies? It may seem dangerous. Orion and other spacecraft can travel at tens of thousands of kilometers per hour, yet they rarely hit anything. The reason is a simple but hard-to-imagine truth. The space between celestial bodies is almost completely empty. Between Mars and Jupiter, there are billions of space rocks. However, the average distance between two large asteroids is approximately 1 million kilometers, almost 3 times the distance between Earth and the Moon. The probability of a spacecraft accidentally colliding with a large asteroid is lower than winning the lottery 10 times in a row. Astronauts do not travel blindly. NASA and other space agencies use supercomputers to map thousands of near-Earth objects, or NEOs. Before launch, all trajectories are carefully calculated to avoid known asteroids. Scientists also choose the launch window to ensure that the positions of the Moon and other objects are as safe as possible. Although they don't fear colliding with mountains of rock, spacecraft do fear micrometeoroids, tiny particles the size of grains of sand, but traveling at extreme speeds. The Orion spacecraft is equipped with special protective layers, such as alloys and composite materials. When a particle strikes, the outer layer breaks to dissipate the energy and prevent it from penetrating the cabin. In low Earth orbit, the greatest danger comes from space debris from old satellites. That is why Artemis II must quickly leave Earth's orbit to enter deep space, which is safer. The spacecraft will follow a special trajectory. It will use the gravity of Earth and the Moon to sling the astronauts around the far side of the Moon and automatically return to Earth without using too much fuel. There are many comments on NASA's YouTube channel asking why Artemis II isn't landing on the Moon and why spend so much money just to fly around it. There are 3 main reasons for this decision. Since 1972, humans have not left low Earth orbit, where the International Space Station, ISS, is located. The Artemis II Orion spacecraft will carry complete systems for oxygen generation, CO2 filtration, and temperature control for humans. NASA needs to ensure that these systems work perfectly in the high radiation environment of deep space before risking a complex lunar landing. The Orion spacecraft is only tasked with transporting astronauts from Earth to lunar orbit and back. It has no landing gear or engines to touch down on the surface. To land, NASA needs another spacecraft called the HLS, Human Landing System. Currently, SpaceX's Starship is being developed to fulfill this role. According to the plan, it won't be until the Artemis III mission that Starship docks with Orion in lunar orbit to carry astronauts to the surface. Landing on and taking off from the Moon are the most difficult and dangerous parts of a spaceflight. Artemis I, unmanned test, already completed. Artemis II, test of human control and life support systems in deep space, upcoming. This will be the official moon landing. This phased approach allows engineers to correct errors in time, such as the heat shield issue you mentioned, before taking the real leap. This is the final exam for the Orion spacecraft before attempting a moon landing. The astronauts will directly verify that the air, temperature, and pressure are stable for the crew, that the spacecraft can maintain continuous communication with Earth over long distances, that the shield protects humans from dangerous cosmic radiation. The mission of Artemis II is to demonstrate that Orion and the SLS rocket are ready and safe to carry humans to the Moon's south pole on Artemis III. Reaching the Moon is already difficult, but returning is the most dangerous part, when the Orion spacecraft must re-enter Earth's atmosphere at speeds of up to Mach 32, approximately 40,000 kilometers per hour, turning the air into a fiery plasma with temperatures nearing 2,760 degrees Celsius that envelops the entire spacecraft and causes a communication blackout during the most critical minutes. After Artemis I, engineers detected a troubling problem. The heat shield was not wearing away in a controlled manner as designed, but instead exhibited abnormal cracks and spalling, forcing NASA to change the re-entry strategy to ensure the crew's safety. Instead of using a bouncing trajectory to reduce heat as planned, Artemis II will use a more direct and steep re-entry, reducing exposure time to extreme temperatures. However, in exchange, the astronauts will experience more intense G-forces, being pressed against their seats as the spacecraft vibrates violently while passing through the atmosphere. We hope that Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen maintain a strong spirit and determination throughout the journey. We hope they have a safe flight, overcome all challenges, and return safely to their families. They represent not only their countries, but also the dreams of exploration for all of humanity. To the ground control team, we wish the engineers clarity and precision in every decision. Their quiet work is the foundation that allows Orion to complete its mission. We chose to go to the Moon not because it is easy, but because it is hard. President Kennedy's words remain true today. We hope that when Orion returns and splashes down in the Pacific Ocean, it will be a moment filled with joy that marks a new step in human space exploration. May Artemis II be a success.